Hello everyone. In this tutorial, I'm going to discuss about the basic concepts of how to set up a HEC-RAS 2D model. So first of all, I will open the HEC-RAS, then I will go to File, New Project, then I will select a drive here. Suppose I'm selecting drive D, then I will select a folder here. Suppose I am selecting the folder HEC-RAS tutorials. So I will double click on it. Then I have to give a name here. Suppose I am giving the name HEC-RAS trial run. Then I will select OK and OK. Then I will go to options. Then I will go to unit system. I will select the unit system as SI unit. Then I will click on OK and yes. So after creating the project and setting up the unit system, I will go to RAS mapper option. So here we can see that the RAS mapper window is here. Then I will go to tools, set projection for project. So here we have to give a projection file, which I have already created in ArcGIS previously. So you can use your own projection file for your particular model, but we have to remember that the projection file should not contain any kind of error. So I will click on this folder sign. So my projection file was saved as bathy.prj, which I have already created in ArcGIS previously. So I will double click on it. So here we can see that the projection file is here. Then I will select the unit system as meters. Then I will click on OK. Then I will left click on this terrain option. Then I will right click on it. We'll select create a new RAS terrain. Then we have to give a TIFF file here to create the terrain file. I have created my TIFF file previously in ArcGIS. You can use your own TIFF file for your model, but we have to remember that the TIFF file should not contain any kind of error. Otherwise, while simulating the HEC-RAS model, we will get error. So now I will click on this plus sign. I will select my TIFF file, which I have created in ArcGIS for my study area. Then I will double click on it. So here we can see that the TIFF file is here. The terrain file will be saved in this particular directory. I will keep it as it is, but we should remember that we should save all the necessary files in a particular folder so that we will not lose the access of any file. So I will press the create option here. So here the terrain file is creating. So the operation is finished and we can see that the terrain file is here. Then I will right click on this terrain option. Then we'll go to export layer, export current image to JPEG. I will left click on it. Then I will give a image name which I want to save. So I am giving the image name as image1. So I am saving it in the same folder where I have created my project. So I will click on the save option. To see the image file, then I will click on this map layer option. Then I will right click on it. We'll go to map data layers, add existing layer. So here we can see that the image file is not visible here. We have to select the other option here. Then we can see that the image file is here. So I will double click on it. So here we can see that the image file is under the terrain file. Then I will click on file, save. Then I will go to view or edit geometric data option. So here we can see that my terrain file is here. To see the image file under the terrain file, I will click on this option. Then I will tick mark the image1. Then we'll click close so that we can see the image file and the terrain file as well. Now I have to draw a mesh as it is a trial line, I am drawing a mesh of rectangular size here. So for doing this, I will click on the 2D flow area option. Then I am drawing a mesh here by clicking of the left click of the mouse. So while at the last point, I will double click on it. Then I will give a name. Suppose I will give it as river. Then I will click on OK. So the area of my mesh is created. Then I will left click on it, go to edit to the flow area option. Then here we can see that there are different options here. We can set up the Manning's value here. To create the mesh, I will go to generate computation points on regular interval with all breaklines option. I will left click on it. Then I can give dx and dy value here. Suppose I am giving dx and dy as 300 by 300. Then I will click on generate points in 2D flow area. So here we can see that the mesh will contain 45988 cells. If we change the dx and dy value, suppose I'm giving it as 350 and 350. Then our mesh contains cell quantity of cells will also be changed. So now I will click on this option OK, and my mesh will be created. Then we have to give an upstream and downstream boundary condition. So I will click on this SA or 2D area BC lines. BC lines means actually boundary condition lines. So I have to select this option to draw the boundary condition line. So I will select this option. Then I will have to draw the boundary condition line. So I will zoom it. So we should draw the upstream boundary here. So I will left click on it and then double click here. So I will give the upstream boundary line as upstream. Then I will select OK. While drawing the boundary condition line, we should remember that we should zoom to the extent, and the boundary condition line, the boundary line should not intersect with the mesh. So zoom in and zoom out, we can go to view, zoom in, zoom preview, zoom out option. Now I'm giving full plot option. Then I can zoom in here for drawing the downstream boundary condition. Again, I will select the SA or 2D area boundary conditions line. Then I will draw the boundary line here. We can zoom it, but as it is a trial line run, I will not zoom in here. I will draw the downstream boundary condition here and will give the name as downstream d by s. Then I will select OK. To have better accuracy, we should zoom as much as possible to draw the boundary condition lines so that we will have no error in the model. So now I will save the geometry data as geometry1. Then I will click on OK. So after drawing the geometry data, then I will go to unsteady flow data option. Then in upstream, I will give a flow hydrograph. So I will left click on it. Then I will select flow hydrograph. Then we have a data file here where we can see that we have discharge and water level data. So I will give discharge data in upstream and water level data in downstream. So I will give a fixed start time here, which I will give 1 January 2005. We can write here, or we can select it from calendar as well. I'll give a time 0000 here and data time interval as 1 day. So if we give 00 here, it will start from 31 December 2004. Actually, if we give 00 time here, it will start 24 hours earlier, which we can see here. So I will copy the discharge data from the Excel file. So we will select it and we'll Control C and we'll paste it on this column, Control V. So here we can see that some of the dates are not visible. So we will select the option use simulation time, then again we'll select the option fixed start time. So here we can see that the days are visible here. If we select the plot data option, we can see that there is flow versus date graph here. We'll have to give a EG slope here. So EG slope is different for different river. So we are giving the EG slope as 0.00007 for this trial run. So I will write the value here and we'll select the option OK. Then in downstream, I will give the stage hydrograph. So I will select the stage hydrograph option. Then in the Excel file, I will select all the water level data and will paste it in HEC-RAS unsteady flow window. So I will Control C it, then I will go to the stage hydrograph window and will give fixed start time as 01 January 2005. Then I will give time as 00 and I will select the data time interval as 1 day. Then I will paste the values here. Then again, I will click the use simulation time option, then fixed start time option. So here we can see that all the dates are visible here. If we click the plot data option, we can see the graph here. Then I will save it, save unsteady flow data. Suppose I am giving a name unsteady data, then OK. Then we have to go to the unsteady flow simulation option. I will tick mark all the options here. Then I will give start time as 1 January 2005 and ending date as 31 December 2005, as we have given data of 1 year. Then I will give the start time as 00 and ending time as 00. And we will give the mapping output interval as 1 day, detailed output interval as 1 day, hydrograph output interval as 1 day, and we can give the computation interval as 30 minutes or any other option we want. But we should remember that the computation interval should be as less as possible so that we will have less error in our model. So to save the time, I am giving here the computation interval as 30 minutes, but you can give as 5 minutes, 10 minutes, or 1 to 2 minutes, whatever you want. Then I will save the file save plan as. I will give the name plan 1, then we'll select OK. Then here I will give plan 1 and we'll select OK. So my unsteady flow analysis file is ready. But we have to do another thing here, that we have created a mesh in geometry window. But what we have to do here, we have to go to the RAS mapper option. Then we have to click on this plus sign here, select the geometry one, then select the 2D flow area option, then click on this plus sign here, and then we have to right click on this 2D flow areas option, then click on the edit geometry. Then again we have to right click on this option, go to the 2D flow area editor. Here we can see that the mesh is not created in this RAS mapper, although we have created in the geometry window. So what we have to do, we have to force mesh recomputation here. After that, we can see that the mesh is created here. Then we will have to close the window and again right click on this 2D flow areas option. Then we will have to click on the stop editing option. Do you want to save edit for geometry one? Yes. Then our mesh is created correctly here. Then I'll save it. Then I will go to the unsteady flow analysis window and give a click on the compute button. So here it is said that time series data needs to span the simulation window. So what is said here, that we have an error, we have to find the error here. So now we have to check what we have done wrong here. So I will go to the stage hydrograph option. Here we can see that our stage hydrograph has not been pasted here. So I will select the fixed time, will give 1 January 2005 here, will give time 00 here, will select the data time interval 1 day here. Then I will go to the Excel file, will copy the water level data and paste it on this window. So here it is, and then I will click on the use simulation time and fix start time. So here it is. Then I will select OK. Then we can save the data file, save unsteady flow data. Then we can give the run here again. So here it is giving a warning. I will click on the OK. So here it is said that property table do not exist and many more. We can reduce the errors by reducing the computation time interval, which I have given 30 minutes here. If we select it less, suppose 1 minute or 2 minutes, then the error will be reduced. If we select 1 minute or 2 minutes, it will take time. To save the time, I have given 30 minutes here. HEC-RAS 2D can show different kind of errors. So we have to find why it is showing errors and have to solve it. So now we will wait to finish the simulation. So our computation is finished. Here we can see that it took almost 20 minutes to finish the simulation. But if we reduce the computation interval like 1 minute or 2 minutes, or even in seconds, suppose we give the computation interval 10 seconds or 1 minute or 2 minutes, then it will take long time to finish the simulation, but the results will be more accurate and the errors will be reduced. So now, after completing the simulation, we can go to the RAS mapper again. Then we can see that the results file is here. So we can left click on this plus sign, select the plan one, then select the depth, then left click on this option, and we can start the simulation from 1 January. So here we can see the animations. So we should select the option play the animation. So here we can see that our simulation is running. So we can see that the water is flowing through the floodplains in some particular months. And here is the river where we can see the river flow. So basically we can see the full animation from RAS mapper. We can also select here the max option to show the max depth. We can also see velocity or water surface elevation. And also we can see the minimum depth as well. So here is the process that how we can set up a HEC-RAS 2D model. As it is a trial run, I have drawn the mesh boundary condition lines very roughly and without proper zooming. But in our real project work, we should draw it very carefully to avoid any kind of errors and to have better results. So thank you everyone. See you in next tutorial.